Hey everybody, I am here in Vienna in a tech hub and I'm with Chris Anderson. I forgot the cable to my mic, so please excuse my audio. Chris Anderson made this amazing database called Fireproof. So Chris, please get a little bit on this introduction about yourself and why we need this new database.
Sure. So I'm here because I've been interested in peer to peer for pretty much my whole career and also interested in making databases super easy to use. So, like a decade ago, I helped build Apache CouchDB and Couchbase Mobile and did a bunch of peer to peer sync and NoSQL JSON stuff. It was good first pass, but it wasn't quite easy enough. It was really, well adopted by people who had a hard problem to solve and needed the technology. But I'd rather build something that everyone wants to use because it makes their coding day more fun and their app faster.
So what does this database do that's different?
I think it's the first serious database that starts out in the browser. So the reason I say that is because it uses cryptographic proofs to ensure data integrity. And when you're working with those kind of Merkle trees and cryptographic proofs, it means it doesn't matter where the data is. So an example of that is IPFS, where you can ask the whole network for a particular piece of data, and whoever gives it to you first, you could trust them because of the cryptographic integrity. So we use that same concept and apply it to database transactions and authorization so that you can do work on your browser, on your phone, at the edge of the network, and have it most of the time automatically merge back up with everybody else's data and do it in a way where the cloud is optional. So you can use a cloud service to keep a backup or a replica. You can also use WebRTC to connect multiple users together and have the data just live on their local. And that's up to you as a developer. My job is just to make it super easy so you choose what's best for your user.
So what are use cases for this? So for example, could you use this for banking transactions?
Okay, yeah, you totally could. Although you might think about how you're doing the banking transactions a little differently. I think it might end up being the right database to do for payroll if you were a company that does payroll in crypto already, because the references to the database states can be linked from the blockchain, and vice versa in a secure way. It's kind of like every transaction is on a side chain already, and you can just check it into whatever blockchain you want. So it's good for that. Although, again, like, yeah, like great to be good for business, but I want it to be super fun for people to build apps with, because I want all the new apps to be this way. So here's an idea for an app that's like a perfect fit. You know, when you're on Chat GPT and you're having a back and forth, and then you get to something you want to share and you've got to screenshot it. Um, because Fireproof uses proofs, it's the ideal database for building an interface like that that can prove that what you have in terms of data actually came from that API. So in the case of building your own front end to the OpenAI APIs, you could use Fireproof plus the HTTPS signatures that come back with the default API responses and fold that full, the actual HTTP response, the thing that's signed, into Fireproof. And then you can prove, based on all the cryptographic integrity, that the entire conversation took place back and forth with an OpenAI API. And you can go back and fork that conversation. With an open source AI toolkit, you could include the model into the Merkle root of your database, because the individual content hash of a terabyte large model is still only a few bytes, and you can include it in your database and get that cryptographic integrity. So say you got the model, the prompt, whatever other parameters, and then the output, and you sign that as the user. Anyone can look at that and get transparency into what you were doing with AI, which I think is going to matter uh, from a debugging standpoint, even as we're building systems that wrap AI with AI.
So I just want to say that as a front end tech lead, a lot of this is over my head right now. I'm going to have to absorb it over a few more times. Um, so this sounds very, very complicated. What is it that get your background that gave you the ability to pull this off well?
Yeah, so I've been with Protocol Labs for a little over a year prior to this, and learned all the ins and outs of how IPFS works. So that's a big part of it. But also building Couch and Couchbase. I've done a lot of database work. I was at FaunaDB for a while. I understand the industry really well. Back to how easy it is, because I just told you how powerful it is. How easy it is if you go on the fireproof.storage website and you see the to do MVC there, that's your copy, right? You can go add new to-do lists and you can modify those, and that's all just resident on your particular instance of the browser. So that was as easy, if not easier, to write than it would have been with a GraphQL API or something. I don't have to do any network access. I just throw a few queries in my React hooks and go.
This sounds like something that could take away a lot of revenue from the cloud providers.
Well, I like to call it cloudless and not because of money, although that does come into it, but because when you're building complicated apps in 2023, like, do you have time to remember which AWS account you have to log into to mess with that? Like, it's just, there's too much complexity, and a lot of it is incidental complexity. Like, why would you care which cloud formation goes with which features? It's all just, stuff that's being forced on you by the environment. If we can build an environment where everything is location independent, now you're just thinking about data and code. It makes it much easier to write apps.
So I can just imagine a lot of traditional tech leads and CTOs will just say, how do we centralize, protect our customer data? How do we data mine our data? How do we just control everything? Can't just have everything living in cloudlessly or our intellectual property.
No, that's a great point. And what it is, people hear peer-to-peer and they think that it's going to be opinionated and make you live in that world, whereas really it's options and it gives you more flexibility for deployment. So one choice with Fireproof is run the whole thing encrypted, run it on your own backend, and query the API from the browser like a regular database. You can totally do that, and it would have the same security profile as any other, database that you can run inside of a perimeter. But
so
I think it's.
Could you just repeat the last 20 seconds again?
Yeah. Just basically to say it, the simple way is you could just run it on your own server and pretend like it's a regular database if you want.
Right. And that would make people like my bosses more comfortable that want to centralize the data and protect it, right?
Basically, it handles all that for you. But the default mode, knowing that we want people to have those options, is to give you the choice between publishing your data unencrypted or to run your, basically the copy of whatever is in your local storage would be encrypted when it's in the cloud. And those encryption keys live in the browser. That's kind of one of the enablers of this is, the new features in the browser that let you do Touch ID or Face ID for password management. So that those new web standards, the Web Auth In is the name of the standard, allows us to get real cryptography for user-controlled keys in the browser. So that gives the idea that you could have the key material that you control and then some unlimited amount of data out there in services land without you having to worry about it being accessed by anybody else.
So where exactly would the private key be stored in the browser?
So it's the APIs for the key management that the browser added. What's cool about them is they use non-extractable key pairs. So you can't get to the key material. All you could do is ask it to sign stuff and encrypt stuff. And that means you don't have to worry about stolen keys. On the other hand, it means you have to build the part that nobody wants to build, where I can delegate an identity from my one device to my other device without moving the key material. And so we also have to build that hard part. But luckily, all this is part of a new protocol group called UCAN, UCAN.xyz, which is it's the authorization stuff. It's like instead of log in with Facebook or log in with Google, it's log in with your thumbprint on your own phone with key material that you control, and then tell the service that you're working with that it's allowed to write to the space that key controls.
So what is it? Someone doesn't want to build?
Oh, it's just so hard, right? This is what's held back crypto for a decade is that if to do it right, you have to have these keys that you can't move. And then you have to build all this like multi-sig stuff about like, oh, I have 2 out of 3 of my phones agree that this laptop should be bootstrapped into my identity. Right? It's like not easy to build the user experience for that.
Right. But you're saying this has already been done by this company, XYZ,
Uh,
dot XYZ.
UCAN.xyz is a cooperative of Fission Codes and Web3 Storage and Blue Sky and a few other big companies that are all solving different problems with it. And just the fact that now the cryptography to support the delegation of identity, that hard research has been done. That's where the investment's going for the user experience. So the user experience is getting there. It's not there, but at least this is a place where the market is going to continue to improve it.
So making a startup using a scheduling system using Postgres, Prisma, front ends, and Solid.js, which is like React. How would this system complement what we're doing? We don't really want to replace all of our stuff with it, but what could we replace parts of it for?
A super easy on ramp is like if you've got an HTML page that you want to add some user customization to. So, like a profile page, and now you want to add another feature where they can make their own playlist and put it in the sidebar or something like that. And you don't want to have to add a bunch of tables on the back end to track that and do like a whole sprint about adding an API for playlist management on just because you want this sidebar feature, right? So instead, what you would do is you would bring in the use Fireproof React hook and then grab that DB instance and write like playlist item 1, playlist item 2 into the local copy, which is as replicated as you want it to be. So it could be that the user only sees their own playlist if that's your kind of app. If the user wants to publish their playlist, then you can, with a line of code, send it to your server, just its identifier, and put it in their page when other visitors go to the page, and now they'll get that playlist. So you can kick off a Fireproof from like, a little UUID sized thing that'll give you the whole app for that user's state.
It's amazing. Normally, you would basically have either a centralized database or you would have something in local storage, but then it wouldn't be replicated. So this just sounds awesome, man. Really awesome. Like,
thanks. Yeah, I've been wanting one of these for a while.
so are you getting much interest right now?
Yeah, it's fresh enough that most of the people who I'm talking to kind of already know me and know what my deal is, and that I'm interested in peer-to-peer databases, so they get it right away. And their reaction is, "Oh my gosh, when can I start using it?" And it's going to be fun to see what the larger community sees as it gets out there. I'll be, I think, speaking in Brussels on April 15th. So there's an IPFS conference happening then. And it'll be good to get that in front of the kind of next wave of audience who's primed to understand it well. But I really do think the people who are going to benefit the most from it are React developers, not just React developers, but front end developers who want to add features to their page without having to do much on the back end beyond like, maybe publishing a cookie if they want that user's state to be shared instead of private.
For me, cookies only seem to be safe if they're HTTP only, so I'm not sure how that would transfer over to this.
I guess I mean a cookie-sized thing, right? Like your whole app is like that little smidge, and how you want to send it around is up to you.
This is just so powerful. Like people that are not technical will not understand how much time and effort this could save, because managing security and settings and databases is so expensive. If we can offload 90% of the insecure stuff, and I'm saying insecure, I'm saying not critical, where people would just go, I just can't imagine all the CTOs that I've worked with would jump onto this and put all the data on it. No way, Jose, right? They would want some lawyers and KYC lawyers and EU data protection audits and all that stuff. But I reckon...
Well, we'll get there. I mean, I've done this before, right? When NoSQL started, that's how people felt about it. And now, if you look at the holiday travel season, this last season here in the United States. We had two major airlines lose like their entire network or big portions of their network due to computer glitches. And United Airlines, that uses Couchbase Mobile, that I built for their pilot scheduling and crew scheduling and ticketing, uh, they didn't have any downtime.
They didn't have any downtime.
Yeah, I mean their thing is designed right because it has this replication that I built into my previous technology. That when the airport's internet goes down, you can still get people on the plane.
What did you code that in? Couchbase
That's it.
Mobile.
Oh gosh, that's a long story. So Apache CouchDB was written in Erlang, which was a trip to get used to, and then Couchbase Mobile was originally, long story short, we got the Erlang version running on the phone, and that burned down the battery like right away in 2010. Um, but then we rewrote it in Objective C just to be as clean as possible on iOS, and in Java to be clean on Android. And then we got good at rewriting it. So then we wrote it in Golang, and we wrote it in .NET, C Sharp. We wrote one in ANSI C. I think, they're probably still writing them at this point.
How does one get good at rewriting your program in different languages?
You have a test suite, right? It gets to the point where like, oh, all we got to do is get it to pass the test suite, and right then it's a kind of a fixed amount of work. You've done it 3 times, so now you're just going to bang out the next one.
Right. So the difference between Chris and me is like the difference between someone who goes to school to learn a musical instrument and the teacher comes in and teaches them how to use this musical instrument. I'm like that kid student, and he's like the teacher in terms of abilities here.
Well, thanks. I mean, I hope really like one of my favorite things to do in my career is show up at like a hack weekend and help people get from 0 to 50% of their app's idea exists, and kind of learn what's the hard part in whatever year it is, and figure out how to make that part easier.
When did you first get access to a computer?
Oh gosh, I think I probably was writing BASIC by the time I was 7.
Yo. I
Yeah.
sat and played games up until the age of 22. Then I started to code. That's how much of a head start you have on me.
I didn't think it was going to be a career. I totally graduated college and went and started recording, rock music and disco and stuff. And it wasn't until my friends' bands this was in the early 2000s. So you'd make 1,000 CDs and you'd put them in the basement and you'd sell them like 5 at a show. And so what were we going to do with the music if you were only selling 5 CDs at a show? And there was no, like, Flickr existed, but there was no SoundCloud. So I taught myself how to write PHP so I could build something like that. And we went out of business, but I learned a lot.
So I've been programming around 14 years. I reckon you've probably been coding around 30. So you've basically almost double the amount of experience as me. So I guess I'm still learning on this growth curve, but did you ever find that you stopped learning as a programmer?
It's a different thing. It's like the stuff that used to stump me doesn't stump me anymore, and then I have a whole different set of things to worry about. And then the stuff that's always stumped me always stumps me. Like, if you want to do a pie chart of my productivity and what I'm actually doing with my time, just imagine me being like, what's going on here? And it's because I left an await out.
So what is it that stumps you?
What I'm getting into these days is like, what does a system look like second order, third order effects, right? Like, it seems like more work to do all this cryptography to make proofs for your data, but really there's a bunch of acceleration that it enables. So how do I build APIs where people who aren't thinking about that get the acceleration anyway, right? And then how do I make those APIs so that people who don't want to think about it aren't like, oh, the other one's easier, It's just got to work.
Could you just like explain that again, except dumb it down a little bit?
Okay, so I'm designing this database, and
Right.
for instance, if I want to include the ability to verify the proofs as they come through your replication stream, um, like that still means that like the thing on your replication stream shouldn't be confusing to look at. So I need to take like the proofs data and stick it in an underscore proofs field so that nobody gets confused that that was something that they meant to save. You know, just kind of like there's going to be things where, say, a user wants to add JPEGs to their database, and I've got to make it so those come back as images and not noise. Right? There's just kind of like the basics.
So say two users are editing the same document, right? And the documents, say user A and user B, and they're making changes on this document. How do you sync those changes so they don't just get like what Grammarly sometimes I'm typing on LinkedIn and it starts putting the the code in the wrong place, you know?
Yeah. Okay, so every change is the change from what it was before to what it is now. So it's not like A is equal to 5. It's more like this change is changing A from 3 to 5. And so that way, when you go to reconcile the changes later, 90% of the time when two different people are working on something, somebody changed A from 3 to 5 and somebody else changed B from 4 to 7, and you could just do both of those. But then there's other times where both people changed A. And so the first thing the system needs to do is detect the difference between those two and then apply the smooth ones smoothly and put the ones that need further attention somewhere you could get to them. And so that's what we have right now. There's a time travel feature in the database. If you go to the demo app, you can click backwards and see like the undo chain. You can see what you did to get there by, you know, adding a to-do list item or marking it as completed. You can roll those changes back, and you can roll those changes back to a point and then do something else instead. But the first work you did isn't lost. It's just, you know, not what we're pointing to right now.
It still
And
sounds
if you
like you've
have,
it sounds like you've re-implemented Git with
yeah, you
some
have to. I mean, there's no other way to do it. They got it right.
so
So
say
I
so
don't.
say so say when we say A, we mean like, see, as program for listeners here, as programmers, we're always worried about the edge cases. So like this, the normal functionality from normal people is we just don't. It's easy for us. But say we have a sentence and we're both editing it, and the sentence says "Hello, the dog." If both, I would immediately start to worry about if both of the carrots are at the O after hello and both persons type at the same time. What does the other user see?
Yeah, right. And sometimes the right answer is to show both users something a little bit silly so they actually see for themselves that something's going on. You
Right,
know,
right.
so there's that too. But in terms of the control that we give the developer, it's about deciding what's inside a transaction and what is two transactions. So anything that's two transactions can be slippery, right? They can be applied, both of them, if they don't talk to the same thing. But if you have one transaction, then you want to apply the whole thing or not. And getting that right is how we would support banking.
Yeah,
Uh,
banking. That's the industry I'm into. Could you repeat that again for
so
the
okay,
dumb banker? Why that is good? Sorry, bankers. I just
there's there's two different concerns in banking, and they're both academic. When computer scientists talk about this, they're not really talking about banking because um, in real life, balances are allowed to go negative. There's like an entire business process for the negative balance. So there's two quote unquote problems in banking. One is ensuring that no transactions ever get lost, and that when they reconcile, it includes all the transactions, right? And then a different related problem is maybe more of an e-commerce thing, is making sure stock never goes below zero. Um, and so keeping your account balance from being able to go below zero is a harder problem than making sure that your bank ledger always reflects the accurate balance. Because you know you can have a process check the balance in one place and then change it in another place, and unless you do like a geophysical lock across both those places, then you're going to need to assume that the database could do could do things across both. So if you want the strong transactions, one of the companies I worked at, FaunaDB, has, I think, stronger math than Oracle or Postgres for, like, let's say you were doing a multi-data center transaction with like a London and New York. Fauna's going to be provably correct, where even, something like CockroachDB is only right most of the time. We would take a different approach to those transactions, or we might piggyback on something like Fauna for multi-data center transactions. I'm currently focusing more on the first problem, which is about how to always report a balance that's, includes everything that happened that we know about, even if it's a negative balance. And so that's
So,
an easier problem, but it's maybe more fundamental for data integrity.
so why wasn't this technology created 10 years ago?
Mostly because crypto wasn't there yet. And by crypto, I mean cryptography. So my view maybe on cryptocurrencies is that as a peer-to-peer geek, I like them insofar as they're peer-to-peer, right? Which isn't really that far. But they have a lot of cool moving parts that we can reuse for peer-to-peer. And that's what I'm doing.
Right. So if you and Linus stood next to each other, who would be the better coder?
Oh man, I'm not really a full-time coder. No, my job is to wish things were so easy that even I could write them, and then sometimes I get stubborn.
So how long have this been in development for?
It's been a vision for like 14 years. It's been a goal specifically, like probably a couple years after I got out of Couchbase, which was, let's say, like 2016 or 17. I started to identify that I wanted to build this, but I knew that the industry needed to come forward a little bit before the infrastructure would be ready to support it.
See, if I was working on something like this, somebody else would have written it because I'd be getting so excited about it. I'd be going about telling everybody about it, and then
Oh, I
I'd be
have
slow.
been.
All right.
Usually that works for me. There's a lot of stuff I didn't have to write. But yeah, to more seriously, the first code, like the oldest code in here, is a couple of years old, but it's an open source library that I've been contributing to for the hash consistent B trees that make it so all that replication doesn't move more data than it has to. But it's kind of a detail, although something necessary. We wouldn't have been able to build it without it. And then the part of the code that keeps track of which updates come in which order for the conflict resolution started in maybe November, December. And both those bits of code were written by team members of mine at my previous role at Protocol Labs. And so they're like the super hacker experts on IPFS data structures. They built these core things that I remixed together and put the front end on to make it so easy that even I could use it.
Could you explain to non-programmers what a hash consistent B tree is, or something like that?
Yeah, sure. Okay. Say you're a computer and someone wants you to have the whole phone book in you, and it's in alphabetical order, and you're gonna go to like Nikos, and so you can't have the whole phone book at one level because it'd just be too big. It wouldn't fit in a page. Everything has to be on pages. So you have these index pages at the beginning to say which pages to look for which letters. And so you might have, okay, the first page says for letter N, go to page 56. And then you go to page 56 and it says for like, NIK, go to here. And then you go there and on that page is Nikos. So that's how all databases work at some level. What a hash consistent version of it does is it means that, let's say, two people are building phone book databases at the same time, independently, but from the same list. But one of them does the list backwards, or they get some of the list out of order as they're doing it. If you didn't use a hash consistent B tree, then you wouldn't be able to tell that those lists were similar. You'd be like, these may as well be completely different lists. You'd have to go entry by entry to realize they were the same. But because it's hash consistent, that little hash ID, the thing I called a cookie earlier, that little bit of data is going to be the same for both of them, as long as they have the same data in them, no matter what order it happened in. And that's the important part, because it means that over time, as you have peer-to-peer, things quiesce instead of getting feedback.
So I stopped nodding my head about 20 seconds into that because I stopped understanding what we were talking about. I don't want to sit here and go like, yeah. I don't want this over my head, but I will go back and listen to it and understand more of it. I mean, if I'm struggling to understand it, everybody that's not a programmer is not going to have a clue what we're talking about.
All right, let me try this again. So let's say you're replicating, right? And I'm going to give you that, that I marked that I had called Nikos at what such and such time. I don't know, whatever's in our database. So, and I'm replicating with you, and we're also replicating with our buddy over here. And so if the trees were not hash consistent, then every time one of those changes bounced around, it would be like a new ID. And then we'd have to be like, oh, we need to replicate. And it would never end. You would get like when you get a microphone and a speaker and you get that feedback sound.
Right.
And so instead, because of this weird math thing, right, that came out of super geeky land, instead of getting feedback, you get it to calm and pause when it's done.
Right. Okay. I get that. Yes. Like feedback with sound. Right. Okay. You could say that this database is like what do you call it when the muffs of feedback? A feedback destroyer database.
Right. Yeah. It's auto merge.
Right.
Yeah.
Wow, this is really exciting.
I would love for people to contribute, right? If you were one of the people listening who are like with me the whole time on what these things are, or even not, but are like, I want to be, open source project, all on GitHub, got issues tagged, like good for starting out with. Reach out, find me on Twitter, jchris. I will, help you learn how the code is structured and code review your stuff, and it'll be a lot of fun. I really like working with community on open source. And if you weren't like that, if you're like, oh man, this sounds like a real database geek, then you should go use it. And if it makes you think at all, like what is happening? Like, please let me know, because that means I need to fix it.
So basically, if you're walking down the street and you meet a movie star you like, you say, hey, Tom Cruise, you Mission Impossible, that's great. They'll meet you and say, hey, Jay, Chris, you saved me 90% of my cloud costs or something like that,
I hope so. And hopefully have more fun doing it, right? It should just be you and that hitting refresh on your page, and it's getting doper and doper.
Cool, man. Cool. So, I guess anything else you want to share? I'll probably get back doing on a podcast for you when we get back more time.
Yeah, I'd say thank you, audience, for sticking with the technical bits, and hopefully this sounds exciting to you. I'd like to hear any little things you tried to build or got built or any of that. It's totally, what I live for, is seeing people put this stuff into practice.
Cool, Chris. Well, I'm going to jump into my bike and go to my next venue. I think you're a cyclist as well, aren't you?
Yeah, have fun out there. I'm jealous of what I see out the window. It looks like everybody's biking.
Oh, this place is pretty cool. Yeah, this is a nice hub here. I use it. You use it for meetups and stuff like that. But I basically hijacked this bit here, so nobody chucked me away. So it was what stealth. What do you call it? Stealth podcasting or something?
Right, you got the corner office.
Fitting a podcast between home and a venue tonight. So anyway, thanks so much, Chris. Appreciate it. See you around.
Take care, Nikos.
And thanks everybody for watching. Until next time.
Cheers.